So for this one, it says from the velocity versus time graph, an object moves on a straight line, which is the distance from 6 to 9 seconds. So we're trying to figure out the total distance from here to here, right? So we're interested in this right here. So remember that the distance is equal to the velocity times time, all right? So the velocity is changing, and this is actually a calculus type question. Notice, and it's called the area under the curve. So the easiest way to do this problem is to figure out the area of this triangle, figure out the area of this triangle, and then add them up. Because it's also delta x is equal to the area of our velocity versus time. Okay? So think of the two triangles. This is a positive. The base from here to here is 2. And then from 0 to 8, so that's 8 units. And so to find the area of this, I'm just going to say the area of a triangle is equal to 1/2 times the base times the height, or 1/2 times 8 times 2. Well, 8 times 2 is 16, right? And then 1/2 of that is just 8. So that means that this area right here, the distance traveled here, is a positive 8 meters. Now this one over here, this triangle, would be negative because it's a negative velocity. Well, what's the distance? It's this from here to here is 1, and then it goes down to -4. So same thing here. The area under the curve is 1/2 times the base, which is 1, times -4. And so when I do the math on that one, 1/2 of -4 is -2. So this area is -2. So my delta x is equal to 8 minus 2 meters, or 6 meters. That's actually a calculus concept where we just found the integral of that. But the problem's rigged up in a way that you could just do simple geometry to find the area under the curve. And if you notice, that was one of our flashcards. We talked about it. It's one of our flashcards. Any questions? Okay. What question is that?